Hey guys, welcome to part 2 of my functions playlist. So in this video we're going to be looking at dealing with what's called composite functions. Now that's things like f(g) of x, gf of x, etc, etc. So let's get down to business. So the first thing that I'm going to say is that I think they've managed to choose the most complicated notation for this. Whenever people have been asked to find f(g) of x this year, they've said to me, that means f times g, does it not? Which is not a silly thing at all, because everywhere in algebra up to now, where we've seen two letters sat next to each other without anything in between them, of course, we've been multiplying those letters. Not with this notation. So f(g) of x does not mean f times g, it means f of g of x. So we're substituting a function into another function. Now I know that sounds completely bizarre. Bear with me, let's see if we can make it make sense. So there are two alternative forms of notation. We've got this guy on the left down here, f, then a little o in the middle with a g, and then of x, so we would read that as f of g of x. So that sort of makes it look like what we're actually doing. The one that we're going to go for is this chap in green, f with then g of x inside a pair of brackets. That's the guy we're going to be rolling with. Okay then, so before we get the crux of this lesson then, let's have a tiny little bit of revision and introduce a new idea. So remember that the number that goes in the brackets after the function's name is the input to the function, and the right hand side tells us what that function is. So here, if we're dealing with f of x is equal to x squared, and we put in our inputs, f of 2 is 2 squared, which is 4, f of 5, 5 squared, 25, and f of minus 1 is equal to minus 1 squared, which will give us positive 1. Now we can also input algebra into our functions. So we can also take things like f of x plus 1. And that goes in exactly the same as just the normal numbers do. So if we take f of x plus 1, the x in the function becomes now x plus 1. So f of x plus 1 here, if f of x is x squared, f of x plus 1 will be x plus 1 squared. So the x has turned into x plus 1. And then if we expand that out, we'll get x squared plus 2x plus 1. If we take f of 2x, then we're substituting x equals 2x on the right hand side of the function. So x squared becomes 2x all squared. So that 2 also gets squared, don't forget about that. So 2x all squared will give us 4x squared. And then if we take f of x minus 10, then we're putting x minus 10 into the function. So we'll get x minus 10 squared. And then if we expand that, we get x squared minus 20x plus 100. Now this bottom half of this page is what we're going to be doing in the rest of this video, substituting functions into functions. So let's get cracking. So example 1 then, f of x is equal to 2x, g of x is equal to x plus 1. Find f(g) of x and g f of x. So in these first two examples, I've tried to use colour coding to help me see what's going on. And then the final two examples, I'll do as we go, writing them out. So let's then first of all look at finding f(g) of x. So again, also I've presented the question in the form that they seem to like putting in the paper. So f(g) of x, not f brackets g of x. But as soon as we start doing the question, we're going to think of f(g) of x as being f of g of x. So we're going to put the brackets around the g of x. It just helps us see, I think it makes it more clear, that we're substituting g of x into f of x. Okay, so as I said then, what we're doing, we're substituting g of x into the function. So everywhere in f of x, where there's an x, it becomes g of x. So here on the left then we've got f of g of x is equal to f of x plus 1, because the g function is x plus 1. So in the f function, everywhere we've got an x, it becomes x plus 1. So we get two lots of x plus 1, and then we expand the bracket, and we get 2x plus 2. So f of g of x is equal to 2x plus 2. Let's have a look at finding gf of x then. Okay, so for gf of x, this time we're substituting the f function into the g function. So again, we're going to bust out the notation g with then the brackets around the f of x. Again, we're substituting the f function into the g function. So everywhere in the g function where there's an x, it now becomes the f function. So we get g of f of x is equal to g of 2x, because that's the f function, and then the x in g of x just becomes 2x. So g of f of x is equal to 2x plus 1. So all that's happened there, the x in g of x has become 2x, because that's the f function. Okay, example 2. F of x is equal to 5x minus 2, g of x is equal to x cubed. Find f of x and fg of 4. So yes, for this first example, we can find a function of its own function. So f of x is saying f of x, which I know sounds absolutely ridiculous. So what we're doing here then, in f of x, everywhere that we've got an x, it's going to become the f of x function. So f of x is f of 5x minus 2. So the x in the right hand part of f of x is going to become 5x minus 2. So then that gives us 5 lots of 5x minus 2 minus 2. Again, this has come from the x turning into the f function. So then if we expand the brackets, 5 lots of 5x minus 2 will eventually become 25x minus 12. So f of x is equal to 25x minus 12. Okay, the next part then, finding fg of 4. So there's two ways that we can approach this problem. So we'll run through both, and as always it's down to you to choose which method you prefer. So fg of 4 then is saying f of g of 4. So we could first of all find fg of x, which then we are going to think of notation wise as f brackets g of x. So fg of x then is going to be f of x cubed. We're substituting the g function into the f function. So that will give us 5x cubed minus 2. So that's f of g of x. Now we want to find f of g of 4. So we actually want to find the value. So now we substitute in x equals 4. So that will give us fg of 4 is equal to 5 times 4 cubed minus 2. 4 cubed is 64. So we got 5 times 64 minus 2, which is equal to 320 minus 2, which is 318. Now method 2, and this is the guy that I would recommend doing because it cuts out a lot of the algebra. You would just be dealing with numbers. If we find g of 4 first, find the value of g of 4, and then just substitute that into the f function. So, to find g of 4, in the g function, x just becomes 4. So g of 4 is 4 cubed, which is 64. Now that we know the value of g of 4, we can just take f of 64, because that is g of 4. So then f of 64 will give us 5 times 64 minus 2, which again is 318. That second method is definitely the guy that I would recommend. In the next two examples though, I'll go through both methods. Okay, so for these final two examples then, I'm going to be going through as we go, writing out the question. It's probably a good idea to see the workings come out as the question unfolds. So f of x equals 2x squared, g of x equals x minus 5. Find f g of x, g f of x, and g g of 2. So let's get to work. Let's find f g of x. So let's think of it with the brackets in there. So f of g of x. So we're substituting the g function into the f function. So that will give us 2 lots of x minus 5 squared. Again, we've just substituted x minus 5 into the x in the f function. So then if we expand that bracket, we're going to be left with 2 lots of x squared minus 10x plus 25. And that will finally give us f of g of x is equal to, multiply through by that 2x squared minus 20x and plus 50. So f g of x here is 2x squared minus 20x plus 50. Let's just get the colour scheme going to show we've changed the question. So now we want to find g f of x. Now this is going to be a lot more straightforward. So g f of x, so for this time we're substituting the f function into the g function. So the f function is 2x squared. Any x in the g function becomes 2x squared. So g f of x is just going to be 2x squared minus 5. Much nicer. Job was a good one. Okay, let's look at finding GG of 2. Okay then, GG of 2. So as promised, I'll roll through both both methods of finding GG of 2. So let's first of all find g of x. So the method I would recommend against. So that's saying g of x, we're substituting the g function into the g function. So we're taking g of x minus 5. So the x in the g function becomes x minus 5. So we're going to get x minus 5 minus 5, which will give us x minus 10. Not such a bad one, this. So then to find GG of 2, we substitute in x equals 2. So g of 2 is going to equal 2 minus 10, which will give us minus 8. Let's have a look at going through the method that I would recommend. So if we find g of 2 first, so g of 2 is equal to 2 minus 5, which is minus 3. And then g of 2, that's exactly the same. Now we know the value of g of 2, so that's exactly the same as taking g of minus 3. So g of minus 3 is minus 3 minus 5, which again gives us minus 8. Both work, both get us to the same answer. That wasn't a particularly complicated one. So it's up to you, as always, which method you prefer using. Okay, one more example. F of x equals x squared add x. G of x is equal to 2x plus 1. So find f of g of 1 and g of f of 1. So for each of these, I'll go through both methods and again choose which one you prefer. If you're feeling brave, of course, pause the video, have a go by yourself. So f of g of 1, then let's sort that out first. So f g of 1, let's go through the method I would recommend against first. So I would find f of g of x first. So we're substituting the g function into the f function. So we're taking f of 2x plus 1. Now then, that's going to give us 2x plus 1 all squared plus 2x plus 1. Good times. Okay, so now we need to expand and simplify 2x plus 1 squared plus 2x plus 1. So 2x plus 1 all squared is going to leave us with 4x squared plus 4x plus 1, and then we've got the plus 2x plus 1 after it. So then finally, that will simplify to 4x squared, and we've got 4x and a 2x, so 6x, and then we've got 1 plus 1, which hopefully gives us 2. So up to there we've now found f of g of x. That's not looking particularly friendly. We now want to find the value of f of g of 1. So now we substitute 1 into that. So that's going to give us f of g of 1. Well, let's take a look at what that's going to be. So 4 times x squared, x is 1, 1 squared is 1. So we've got 4, add 6 times 1, which is 6, and then add 2, and that's going to give us 12. So that's quite a good example of why I would advise against using that method. Let's have a look at doing the same thing with the other method, K. Okay, so this time then, we're going to first of all find g of 1, and then substitute that into the f function. So g of 1 is going to equal 2 times 1, add 1, which will give us 3. So now we know the value of g of 1, we can simply substitute that into the f function. So f of g of 1 is equal to f of 3. And then finally, we substitute 3 into the f function, so we get 3 squared plus 3, which is 9 plus 3, which again is equal to 12. So let's compare the workings to that, to the guy that we just did before. I definitely know which method looks friendlier. I would definitely recommend going for this method. Okay then, finally for this video, let's have a look at finding g of f of 1 this time. So this is going to be nicer than finding f of g like we just did. So again, we'll start off with the method I would advise against. So first of all, we need to find g of f of x. So we're substituting the f function into the g function. So that's going to give us 2 lots of x squared plus x plus 1, which can go down to 2x squared plus 2x plus 1. So that's our g of f of x. Now we need to find the value of that when x is equal to 1. So g of f of 1 is equal to 2 times 1 squared, 2, plus 2 times 1, 2, plus 1, which will give us 5. So g f of 1 here is equal to 5. Let's run through the method I would recommend. So let's first of all find f of 1. So f of 1 is equal to 1 squared plus 1, which will give us 2. And then to find g of f of 1, we just substitute now in 2 to the g function. So g of 2 is equal to 2 times 2 plus 1. Happy days. 5 again. Okay guys, that's composite functions. Let me know how you found the video. I'm very curious. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers, guys.